Let's start with the first one. Okay. Diagram shows the nuclide notation of an element. Nuclide notation of an element. All right. Okay. A is the nucleon number, Z is the proton number, X is the symbol of element. Okay. Table 6.1 shows equation, okay, of the decay process of radioisotope uranium and radium. Okay. By using both equation in table 6.1, calculate the difference of nucleon number between uranium and thorium. Okay, see carefully. Uranium is 238. Thorium is 234. So, oh, I didn't do A first, right? What is the meaning of radioisotope? Let's call Alim. Alim, what is the meaning of radioisotope? Alim. Satish, help him.
What is radioisotope?
The meaning of radioisotope. Isotope of a radioactive element with what? With an unstable nucleus. You can continue. Isotope of a radioactive element with an unstable nucleus. You even continue and tell which undergoes a nucleus decay to form, a stable nucleus by emitting radiation. You can keep on going also. Alright? But normally when they ask what is a radioisotope, you just tell isotope of a radioactive element with an unstable nucleus. Alright? Okay. You can continue and tell which undergoes nucleus decay to form a stable nucleus, alright, by emitting radiation. Can also. Wait, just check outside ada orang ke tak? Yes. Adeline is there. Hi, Adeline. Taeyang, you okay? Check Chuan is missing now. Alamak. Taeyang is in Check Chuan, Started lah. Check Chuan is missing. Okay, next. Okay, by using both equations in table 6.1, calculate the difference of nucleon number between uranium and thorium. Just I told you, uranium 238, thorium 234. So, calculate the difference of nucleon number. Nucleon number difference will be 4. 4. Radium and radon. Radium and radon. Radium is 2 to 6. Radon is 2 to 2. So what is the difference? Again 4. Again 4. By using both equations in table 6.1, calculate the difference of proton number between uranium and thorium. Proton number, uranium 92, thorium 90. So, calculate the difference of proton number 2. 2. Right? Okay. Oops, sorry. Okay, done. Radium and radon. Sama jugalah, 2 lah. Tengok, 88 and 86. See here, 88 and 86. So, samalah 2, So, radium, radon, 2. Okay. Based on the answer, when an alpha decay, when an alpha decay process occur, okay, the nucleon number decreases by 4, the proton number decreases by 2. All right. When an alpha decay occurs, the nucleon number decreases by 4, proton decreases by 2. Okay, any question? Anyone, any question? Hello? Anyone, any question? Other? Okay, now see here. Diagram 6.2 shows a radioisotope which emits alpha particle. In diagram 6.2, complete the path of alpha particle when it enters the region between two metal plates. Complete the path, okay? Complete the path of the alpha particle when it enters the two metal plates. This is positive and this is negative. We know for sure alpha is positive. So alpha will go this way. Jang, jang, jang. Jaden, why alpha went this way?
Because alpha positive attracted to negative. Oh?
Very good. Electrostatic force. Okay, next. Give one reason for your answer. Alpha is positively charged, electrostatic force attracted it. Alpha is positively charged, electrostatic force attracted it. Okay, next. Oh, I even teach you all half-life. Okay, let's look at the notes for a while. Half-life. Must see half-life today. Right, here only, right? Okay, must see half-life today. Half-life. Where's your notes? Okay, we saw this on Monday, right? All this we saw on Monday. Okay, today we will start with radioactive decay series first. Series first. Okay, see here carefully. Before I go to half-life. Okay. Radioactive decay series of uranium. Okay, see here. All right. Okay. If you see here carefully, on your left, all right, this is the nucleon number. All these are nucleon number. Nucleon number 222, 226, 230, 234, 238. Who's coming now?
Jishuan.
He also later. You supposed to be a leader. Okay, on the left is nucleon number. Bottom here, axis X is proton number. Proton number. Okay. How do we write an equation? See here carefully. How to write an equation? Okay. See carefully. Okay, first thing. Take this uranium. Okay, uranium. See the uranium's nucleon number 238. 238. See the uranium's proton number 92. Then decay arrow shows it's forming thorium. Thorium. And then see the nucleon number of thorium 234. 234. Then see the proton number 90. 90. So now plus, definitely it's going to be 238 minus 234, 4. 92 minus 92, alpha. Plus energy. Okay. What is actually happening here is that, sorry, we have a decay of uranium finally becoming radon. All right. So during this decay, it don't happen one step. It happens 6 times. 6 or 4 times. 1, 2, 3, 4 times it occurred. So first the uranium decayed to form thorium. Then the thorium decayed to form some papaya or papa, whatever lah, PA, papati or papaya. Okay, next, it again form uranium. Then form thorium again, isotopes. Then form radon, radium. This is radium, I think so. Then radon, all right? So it's a series, 4 times it occurred, all right? 6 times. 1, 2, 3, 4, 4, 5, 6 times. So we're going to try to identify all that now. We only wrote the first equation. We only wrote the first equation. We're going to write the equation according to number of arrows. See, the arrows are number of arrows. Okay, now the second one starts from thorium to Pa. So thorium is 2, 3, 4, 90. 2, 3, 4, 90. And then it forms, okay, Pa. Pa, when I check, it is 2, 3, 4, 91. 2, 3, 4, 91. All right. Plus 2, 3, 4, 2, 3, 4, so 0. Minus 1 plus 91 is 90. This is beta. This is beta plus energy. This is how we write. Any question? Who got problem? Anyone got any question? Hello? Hello? Okay, next one. So we wrote the first one done, second one done. Now we go for the third one. Pa to uranium again. See here. Pa, whatever like papaya, papalium, whatever lah. Pa 2, 3, 4. Proton number 91. Then becoming uranium again. Proton number 92. Nucleon number still the same, 2, 3, 4. 2, 3, 4. Plus, what was emitted now? So we're looking at the series, uranium turn, finally become radon. And then what happened here during the process? It is releasing one step at a time. In the first equation, it released 1 alpha. In the first equation, it is 1 alpha. Second equation, releasing 1 beta. Third equation, what is it releasing now? Beta again. Beta again plus, of course, energy lah. Plus energy. So we wrote 3 equations already. 1 done, 2, third one done. Now we got another 4th, 5th, and the 6th one. Okay. 1, 2, 3. Any question? Marcus, you have problem?
No
Kavin?
problem. No problem.
Thank you. Kavin? Alfred?
No problem, teacher. No problem. Can
Thank you. Alfred? Alfred, any problem?
No problem.
Thank you. Nigel? No problem. Sure. Adeline, any problem?
Mr.
No.
Don't let Tam Jashan in.
Tam Jashan. Why is coming so late?
I also don't know.
Mr. Tam Jashan, the class starts at 11 a.m. and you are with the same time frame with us in Malaysia. So if it's 11 a.m. for all of us, it's the same 11 a.m. for you also. Mr. Tam Jashan, are you listening to me? Tam Jashan, are you listening or not? Don't let me kick you out of the class. Please be on time next time, Mr. Tam Jashan. Mr. Tam, can you listen to me or not? Or is this purposely entering? Okay, let's continue. So now I wrote equation 1, 2, and 3. Okay, let's try equation 4, 5, 6. I want all of you to write. I'm going to call somebody. Equation 4, 5, and 6. Okay. Cepat, seorang cuba. Okay, let's start equation 4. Kalok.
Yeah.
Mr. Ng Kalok. What is the nucleon number? Yi Sam Si. Correct.
Yeah.
What is the proton number?
92.
92. Okay, arrow. What is formed in equation 4? Thorium. Thorium, what is the nucleon number?
230.
230. What is the proton number?
90.
90 plus. So what was released?
Alpha.
Alpha. 4 to helium. Plus energy. Plus energy. Okay, very good. Now equation 5. Equation 5. Let's call Sandra. Hi, Sandra. Okay, we start with thorium. What is the nucleon number? 230. Proton number 90. What is the product, Sandra? Radium. Okay. What's the nucleon number? 226. Proton number 88. Okay, what was emitted, Sandra? When thorium changed to radium, what was emitted? Alpha. Alpha. Thank you. Alpha plus energy. Okay, thank you. Okay, done. Equation 4, equation 5 done. Okay, the last equation now. Last equation. Okay, equation 6 now, the last one. Okay, we call the leader, he himself. Radium 226, 88. The product is radon 222, 86. Sean Wong. What was emitted? What was emitted?
Alpha.
Alpha. Thank you,
And
boy.
then energy.
Thank you. Okay, now one question to who should I ask? Averil.
Yes, sure.
Averil. Okay, how many times alpha decay occur? How many times? How many times alpha? 1.
4.
Yes, very good. 4 times. 4 alpha decay. How many times beta decay occur, Averil?
Twice.
Beta decay occur twice. Very good. 1 and 2. Very good. Beta decay. Fantastic. Okay, done. So this is what we call as a series of decay. We call this a series of decay. This is the last equation. Okay, now we'll go to half-life. Half-life and how to calculate half-life. Okay, remember this. Every radioisotope, radioactive elements, they are having unstable nucleus. Therefore, they will have a time frame called half-life. Uranium-238 will have 4,500 million years of half-life. Carbon-14 will have 5,730 years of half-life. Radium-1620 years of half-life. Cobalt-60, 5.3 years of half-life. Phosphorus-32, only 15 days. Iodine-131, only 8 days. Okay, now we look at the bigger picture of half-life. How does it work? Okay, dengar. Okay, half-life can be learned, okay, in a way like this. First, you think few method, by fraction method. If the initial amount of radioactive substance is given as 1, after the first half-life time frame, all right, the remaining balance will be half from the initial amount. So what you should do, you should take the 1 times 1 over 2. Then after another half-life, time, the half you have to times by another half. So you get 1 over 4. This is fraction method. After another half-life, you take the 1 over 4, you times with half again. You get 1 over 8. So this is how the half-life system works. The half-life system works in such a way that if you look at fraction method, the 1 become half, the half become 1 over 4, the 1 over 4 become 1 over 8. This is one method. The second method is by percentage. Okay. If you have 100% initial amount, after the first half-life time, the remaining balance will be 50% from the initial amount. So what we did, the 100%, we times by half, we got 50%. Then after another same half-life time, you must understand, guys, if let's say I give you example, iodine 131. Iodine 131 has a half-life time of 8 days. 8 days. So all these are perfect 8 days. Every 8 days. All these are perfect 8 days. Every 8 days. Right? So what is the remaining balance? You take the 50. You times with another half. You get remaining balance 25%. After another half-life, all right, another half-life, 25, you times with half. Another half-life. What is the remaining balance you'll get? You will get 12.5%. This is the remaining balance. So, if you see here, first method, we look at fraction method. 1 becoming half, half becoming 1/4, and 1 over 8. If you look at the percentage method, 100% becoming 50%. So the initial amount, we always consider the initial amount as 100%. Initial amount, we always consider as 100%. Okay. Another method, so first is fraction, second is percentage. The third method to understand half-life is we go by count, the count rate. The count rate, the count rate can be in 2 modes, as I said the other day. Count per second or count per minute, whatever question they are giving you. How do we understand? Let's say initial amount. This is an example. Let's say the initial amount is given as equivalent to 4,000 count per second. So this is the initial amount. So initial amount is 4,000 count per second. So after the first half-life time frame, the remaining balance will be 2,000 count per second. After another half-life time frame, which will be equal,
You haven't let Ming Chun in.
Ming Chun coming so late.
Yeah.
Ming Chun, Darshana, Shwansin. Ming Chun, you are very late. Shwansin also.
I think he has something left.
In a divide.
I mean, just now.
Lim Ming Chun,
Yes,
you are very late. Very
sorry.
late. Baru bangun kah? See Tae Yang.
Yeah.
Learn from Tae Yang. He's so responsible nowadays. He come for class on time.
Tomorrow he
Thank
will
you,
be
Tae Yang.
gone now.
Thank you, Tae Yang. Okay, now see. First, we were looking at half-life in the idea of fractions. Second, we are looking at half-life in the idea of percentage. Now we are looking half-life in the idea of count rate amount. All right. So initial amount was 4,000. After the first half-life, 2,000. Second half-life, first 2,000. Now the second one will be 1,000 remaining balance. Remaining balance is 1,000. After another half-life, it's the third half-life. It will be 500 counts per second. So now for this example, half-life, number of time half-life occurred 3 times. 3 times. 3 times. If I say, for example, the half-life is 10 days. 10 days. That means each half-life is 10 days. So total time taken. So total time taken will be a perfect of 30 days. Why 30 days? You count lah. 10 plus 10 plus 10. Total 30 days. 30 days. Alright? And each of the half-life took a time frame of 10 days. Each of the half-life take a time frame of 10 days. So total 30 days. Alright? Okay. Another method, ada 4 cara. One more method. So I repeat again, we were looking at the fraction, percentage, count rate. Now we go for mass. The next method is by looking at the mass. Mass. Alright? Maybe in gram, maybe in kilogram. How they give. Microgram also they'll give. So when you look at in the form of mass, what we should know here is that, let's say initial amount given is 800 gram. So after the first half-life frame, the remaining balance will be 400 gram. Remaining balance will be 400 gram. After another half-life frame, the remaining balance will be 200 gram. So now how many times half-life occurred? 2 times. 2 times. If each half-life takes a time of 20 minutes. 20 minutes. So now the question is, what is the total time taken? So total time taken now will be 40 minutes. And one more question now. Each half-life is 2 minutes. What's the total time taken? 40 minutes. One more question now is that, let's say I ask you, what is the remaining balance? Remaining balance here is a perfect 200 gram. What is the amount decayed? Amount decayed. The amount decayed will be 600 gram. 800 minus 200, 600 gram. So to look at half-life, we have to look at 4 methods. Fraction, percentage, count rate, and mass. We also have a formula method. The formula method will be, see the formula, just now you saw in the notes there. Alright, this is the formula. N equals to 1 over 2 power small n times NO. Okay, what does this mean? Okay, what is the idea of this? The idea of this is, the N is the remaining balance. The balance remain. What is the amount of balance? This is the balance. Okay, I better go there lah. Here, remaining balance. Okay. The small n is the number of time. Number of time the half-life occurred. The NO stands for initial amount. Initial amount. The NO stands for initial amount. Initial amount. Okay. So now this is the formula. All right. The N is the remaining balance and O is the initial amount. The initial amount. And the small n is the number of time it occurred. T half is the time of half-life. It can be any time given here, you can see. Okay, let's try one question, see whether you all understand or not. Okay, number one. A radioactive substance takes 168 seconds to its activations to decrease from 960 per minute to 120 per minute. What is the half-life of this substance? You were supposed to find the half-life, okay, of this substance. So, substance takes 168 seconds to its activation to decrease from 960 to 120. So, see what happened. Activation from 960 per minute to 120 per minute. So, initial amount was 960. Remaining balance is 120. So, remaining balance is equal to 1 over n times NO. So if you do it, 120 equals to 1 over 2 power n times 960. So what will you get? You'll get 2 to the power of n equals to 960 divided by 120 is 8. So n is equals to 3. Now you get 3. So when the n is 3, total time, there's another formula. Total time is equal to, total time is equal to number of time the half-life occurred times the time of half-life. So total time given 168 seconds. The number of time half-life occurred 3 times. So what is the time of half-life? So the time of half-life equals to 168 divided by 3, 56 seconds. 56 seconds. 56 seconds. All copy already? Semua sudah salin? Semua sudah salin? Sean, you copy already, Sean?
Wait. I don't understand the first part.
Okay, wait. Wait, you copy first, I explain again. You copy first, I explain again. Okay, the idea here, initially it was 960 count per minute. Then after some time, the balance is 120 count per minute. So after some time, the balance is 120. Initially, it was 960. So by using this formula, we are trying to find out how many times half-life occurred. How many times half-life occurred? We found out 3 times. 3 times. There's another formula. Total time is equals to number of time half-life occurred times the time of half-life. So we realize it's 56 seconds. Ini satu method. Okay, semua faham ah? Sepadam, ah? Okay, there's another method, see here. Another method is the easier way lah. Okay, but formula, all of you must know the formula. What is another method? This is the kacang method. The kacang method is sangat-sangat senang. Okay, initially was 960. After the first half-life, what should be the balance? Hello? 480. After another half-life, what should be the balance? Hello? Hello, hello? 240. After another half-life, Ming Chun,
Yes.
what is the remaining balance?
120.
240, 120. Okay, now, Ming Chun, how many times half-life occurred now? Yat,
3 times.
Yi, Sum. Yes. Half-life occurred 3 times. So the total time was 168 seconds. Just divide by 3 lah. You will get the half-life time. 160 divided by 3, you get 56 seconds. That's answer lah. Siapa tak faham? Yongsin, understand or not?
Yes.
Thank you. Okay, now we try number 2. Okay, number 2, Number 2. Number 2. A sample of iodine 131 to have activity of 800 count per second. What will be the number of activation after total time taken is 16 days, right? And the half-life, each half-life is 8 days. Okay. What is the remaining balance? That's what they want. What's the remaining balance? Okay, let's see. Okay, first, we have initial count, 800 count per second. This is the initial count. All right. We have to find what is the remaining balance, tatau. We know that total time formula. Total time is always equal to number of time half-life occurred times the half-life time. So half-life occurred for 16 days. Total time lah. How many times it occurred, we do not know. Each half-life is 8 days. So we know the half-life occurred for twice. 2 times. So now the formula says n equals to 1 over 2 to the power of n times NO. So n equals to 1 over 2 to the power of 2 times initial amount 800. So n equals to 800 divided by 4, 200. 200 count per second. The remaining balance. The remaining balance. The remaining balance. This is the remaining balance. This is the remaining balance. Or you can do another way also. Simplest way. Simplest way, you take 800 count per second. You know the total time 16 days. Each half-life is 8 days. You know this. So number of time it occurs twice, only twice. So first half-life drop to 400 count per second, first half-life. 400 will drop to 200 count per second. second half-life. Done. This is the answer. Anyone got any question? Hello? Jika anda ada soalan, boleh tanya sekarang. Ini pakai formula. Ini pakai formula. This is the initial amount. You look for the final remaining balance. Look for the remaining balance. Alright. And then this is the formula lah. Formula. And this is another formula. Ada dua formula saja. Satu, dua. Use the formula, you get the answer. If you don't use the formula, you direct use the logic. 800 will drop to 400, 400 drop to 200. That's it. How many times have to drop? Twice. Done. Okay. Anyone got any question? Hello? Jika tiada, kita kembali. Ada soalan? Okay. Now dengar. This one done already, ya? 200 pound per second. Okay, now. Number 3. All try. Semua orang cuba. Phosphorus 32. Phosphorus 32. I'm going to call. Who should I call? I want Marcus Chong Chi Peng. Mr. Marcus Chong. Assisted by Xin Yi. To explain. Phosphorus 32. Half-life is 15 days. How long will it take for 75% of its substance to decay? 75% to decay. How long will it take? So I want the total time lah. I want the total time. How long will it take for 75 of its substance to decay? If you don't use the formula also can. No issue. Each half-life is 15 days. For 75% to go off. So the remaining balance is only 25%. How long will it take? Marcus boy? Tun Marcus, are you there? Marcus also Tun M, you know. Because Tun Marcus. Yes. Konga.
I don't know.
Very easy, boy. See here. 100% will drop to 50%. So what is the loss? 50%. Okay. 50% will drop to 25%. So if you lost 75%, remaining balance is 25%. So here there's another loss of 25%. So what is the total loss now? 75%. Total loss is 75% gone. So 75% has decayed or gone already. The amount decayed is 75%. What is the remaining balance? The balance is 25%. Balance is 25%. So how long will it take? So first half-life, second half-life. So 2 half-life. It took 2 half-life. So each half-life is 15 days. So what is the time? So total time taken. Tun M, what is the total time?
30.
That's it lah. 30 days. Who don't understand? That's it lah. That's answer. 30 days. That's answer. So phosphorus 32, 15 days half-life. How long will it take for 75% to decay? 75% gone already. So the remaining balance is only 25%. The remaining balance is only 25%. So first decay, first half-life, 50% gone. Another half-life, 25% gone. That's why total loss is 25%. Balance is 25%. 30 days. Sean and Sean, the two brothers, do you understand now?
Yeah.
Thank you. Okay, Pritisha. Pritisha, can you hear me? Pritisha. Try number 4. All of you try number 4, 5, 6. All try. Pritisha, do number 4. Give me answer, girl. All try. Okay, first question. Each half-life is 10 days. 10 days. After 30 days, what is the percentage that have decayed and what is the balance? Okay, let's try. First question. Pritisha. Pritisha, where are you? Okay, first question 4. Question 4. The half-life given was 10 days. Okay, now after 30 days. After 30 days, right? Okay, after 30 days, what is the percentage that have decayed? Percentage that gone already, all right? And what is the balance? So 30 days, each one is 10 days. So what you do, 30 you divide by 10. You'll know the number of time it occurred. So it occurred 3 times. If it occurred 3 times, we are talking about percentage. So take the initial amount always as 100%. So 3 times it occur, initial amount 100%. Okay. So after the first half-life, the balance is 50%. Okay. Another half-life, the balance is 25%. Baru 2 kali, 1, 2, twice only occur. The third time, because it shows 3 half-life, the remaining balance is 12.5%. So now we answered the question already. You have to give what is the amount that have decayed and the balance. So the amount have decayed. The amount decayed. The amount decayed will be 87.5%. The amount decayed is 87.5%. All right. The balance is 12.5%. The balance is 12.5%. Okay, done. Then we go to question 5. Any question? Anyone got question? Question 4, anyone got question? Ada soalan ke? Soalan-soalan? Sekiranya anda ada soalan? Ada? Anyone? Mr. Pang Chi Wei, ada problem ke? Pang Chi Wei. Mana dia? Mr. Pang, do you have any problem?
He didn't even connect to audio, sir.
Yeah. Don't know, he turned on and cabut already or what? Pang, are you there, Mr. Pang? Ritisha, why you don't want to talk? Okay, next we are looking at question number 5. So number 5, okay. The half-life for number 5 is given as 20 minutes. 20 minutes. Okay. Now, the fraction left after 1 hour. So total time is always equals to number of time half-life occurred times the time of half-life. Total time is 1 hour. 1 hour is 60 minutes. Number of time occurred, each half-life is 20 minutes. So, the number of time is 3 times. 3 times. So, they want to know what is the fraction left. What is the fraction left? So, the fraction left, 1 will become half. Half will become 1 over 4. And 1 over 4 will be 1 over 8. So what is the fraction left? 1 over 8 from the initial amount. 1 over 8 from the initial amount. 1 over 8 from the initial amount. Any question, guys? 1 over 8 from the initial amount. Siapa ada soalan?
Sir,
Yeah.
why did you use 1 then became half? Why is
Because
it 1?
this is fraction. When fraction, we assume the initial amount was full. After the first half-life, only half stays there.
Oh, okay.
After another half-life, only a quarter stays there. Clear?
So if it's fraction, we assume it's 1 lah, total.
Yes. Yes, sir.
Okay.
All right. Okay, we go back to the last question. The last question, number 6. Darshana, do the last question. Try. Darshana and Chai Ruby and Yong Sin and Pascal marah pula. Celine Chong and Tam Jiashen and Nigel. All try. A fossil bone shows activations of 1 over 4 from initial amount of carbon-14 activations. If the half-life is 5730 years, find the age of the bone. This is how we know the age of the bone. I tell you, nowadays nobody can cheat anything. We can do a carbon dating like this and identify every time frame perfectly. You come and bring and tell me this one belongs to my great-great-grandfather who's keeping it for 5,000 years, I'll tell, give me. I check the carbon dating. Check the carbon dating, it is not even 15 years. So we can detect every age of things around us, we can detect, especially organic substance, very easy to detect. Okay, what is the answer? The whole team asked you all to do. Hello? Woohoo! Apa jawapan? Jawapan anda apa dia? Fizik. Fizik. Oh, now it's 114. Hello, sudah ke? Who can give me answer? Hello.
11460, sir.
Yes, very good. So, Darshana, what's the answer, Darshana?
I'm not really sure how to do, sir. I don't know,
Okay,
sir.
see here. Okay, see here. The remaining balance is 1/4. So before it become 1/4, it should have been half. Before becoming half, it should have been 1. Remember just now I did? Every time when you have a fraction method, 1 will become half. Half will become a quarter. So the remaining balance is 1/4 from initial amount. So
We can't see
initial
your
should have
screen.
been 1. Huh?
Are you writing
You
anything?
cannot see. Oh, sorry.
Oh, sorry.
Good morning,
Technical
Mr.
error.
Peter. Good morning.
Morning.
Technical error.
Rise and
Tun
shine,
M.
Mr. Peter.
Rise of Kingdom.
Tun M. Tun M. Okay, see here. 1 become half, half become quarter. So number of time occurred is twice. So what was the formula we have? Total time. Total time will be equal to number of time it occurred times the time of the half-life. So number of time it occurred twice. Half-life is 5730 years. So we get 11460 years. This is how we can detect half-life of all the things around us. All right? Okay, very good. One more thing to do. See here, this is the graph of number of activity against time. The graph of number of activity against time. Okay, how to look at number of activity against time? Okay, see here. First, you have to just give one amount lah. Okay, let's say you put one amount. This is initial amount. Remember, initial amount and O, right? Or I give you 8,000. Contohlah 8,000 count per second. So this will be the first half-life. Okay, this is half-life. Okay. So this is count. Count per second. Okay, now. So this will be the second half-life. So this will be the, give me a few more minutes, guys. It's now only 12 o'clock. I know you all are not hungry at all. Okay. This is the third one. Shankar, tahan kejap. Fourth half-life. Okay. Or if I say half-life is, let's say, 8 days. 8 days. And let's say half-life is 8 days. Okay, 8 days. Maybe this is iodine 131. Okay, so what we can do here is that we can just take away all these, then we can tell, hey, sorry. Then we can tell this as 8 days, as I put 8 days, right? Right. What happened? Come on. It's not stable. Sorry, Okay, see here. This is the count rate, right? Maybe count per second. This is the half-life. Half-life. Okay. Maybe it is 8 days. Yeah, 8 days. So what we'll get here is 8. Then 16. Then 24. Then 32. All right. So what will happen is that if this is the initial amount of NO, let's say 8,000 count per second, NO. So exactly half of it, 4,000. 4,000. All right, then exactly half of 4,000, 2,000. Exactly half of 2,000, 1,000. This is how the graph will look like. See carefully. So first at 0 time frame, it was a perfect here, here. Then after 8 days, it will be here. After 16 days, it will be here. After 24 days, it will be here. So you will get a perfect curve. You must get a perfect curve. Your curve must be very much perfect. Ayo. Susah saya melukis curve. You must get a curve like this. You must get a curve like this. You must get a curve. Must get a curve. And remember, jangan intercept the curve on axis X. So every time when you have a decay series, your curve will look like this. Zing, like that. This is the half-life. This is whatever lah, activity. Right? It can be mass, it can be count, it can be fraction, it can be percentage. So every time you get a half-life graph, decay, your graph, it's a curve. It's a curve, a perfect curve. All right? This is how you get. Any question, anyone?
No question, no
Adakah
question.
Anda ada soalan? Jika tidak ada soalan,